Hello, ladies and gentlemen, boys and girls. My name is OctoMan, and in this live stream, I'm going to continue working on the prototype for uh, the game idea Missile Command, which was a rather popular game on the Atari system, and also there are multiple new versions of that, I believe, probably outside over there. I'm going to tackle this one in 3D since I think 3D is a bit more, different than 2D. Well, in general, it's not, but you can make more with the look if you want to, and please and like. This prototype is later on going to be available on my website for purchasing. So whenever you think you want to work on the title on your own, meaning you want to have all the systems, but you want to go and actually update the assets, for example, then you're absolutely able to do so. Hi, thanks for tuning in, Time Pass. I'm glad you're here. So in the last video or in the last live stream yesterday, we were creating literally everything necessary for the missiles coming from top to bottom. So they're choosing a random target, which is not going to be down below. We now gonna go for the opposite direction, meaning whenever we do a click somewhere on screen, I want to paint some kind of a, let's say, aiming cross or something. So I'm going to put something simple together, like an image or two. Position this one on screen, which is going to be like on the 2D surface. So we need to know where do we actually press when we click on the game? Where is it in the 3D space? And then the next thing is going to be we need to know where to shoot the missile from, or where to shoot our projectile or a laser beam or whatever it's going to be later on. That is totally up to you as well. So we're going to shoot until we reach that point we just clicked in 3D space. We know that we are on the z-axis, literally on 0, 0, 0, or just on 0 on the z-axis, so we don't need to go like somewhere far away and so on. The missiles usually shoot just literally straight ways over here. So it might happen that they're going to go through this height of buildings. So probably they need to be just, reduced. So they are all the same height over here. So when we shoot from here to here, that they don't intersect with the other buildings, which wouldn't be an issue because the missiles we are going to use are going to have a different, let's say, tag. So they probably, or no tag, so we don't have any issues with the buildings, whatever there's going to be. Again, we can also lift these balls over here, which can be like a satellite or something like a anything. Hello and welcome, F-Play. Thanks a lot for tuning in. So in this case, we can think about, okay, lifting them up so they're going to be a bit higher than the other ones. The defense system in general can be anything. So you are absolutely totally free. It doesn't have to be something like a rocket launcher. It can also be something like a bug shooting a gumball, or you can do anything. It can be a gumball. It can be something out of the nature. It can be water, right? Like if you have like, I don't know, you can say, okay, you're gonna let raindrops fall down over here. And so the theme is going to be totally up to you. Everybody can do its own theme. So, and we're gonna have maybe some small fireplaces over here, and people are grilling, their food or something. Like if you're like in the Stone Age, just think about it. And these ones here can be something like whatever is going to make away rain drops, for example. Or you can do anything you want. You can also, once again, do something like an ant nest or something, where you have like ant eggs to be protected here, so they don't break when rain falls down, or whenever sand is going to swirl around and so on. There are so many possibilities for you to implement a game idea, which is one thing. It's the actual prototype. The other one is doing the design. You can make this a super fancy whatever design, literally. In the background, you, by the way, can also put some terrain like mountains and stuff like that. So you can be super creative. You can make a one world next to another. You can go absolutely in any direction. Again, the prototype just means that we're going to prepare systems which are working hand in hand, but it doesn't matter who you define to be some kind of a building, or some kind of a defender, and something to be protected. Same for later on if it comes to pickups, like if there's a shield going to fly around, or a shield kind of system. It could be, and when it comes to nature, it might be a leaf which protects the egg of an ant and so on. So these shields can be picked up, and then we just blend them over all the buildings or all over the eggs or whatever this is going to be, like a seam wise. So today I want to tackle the shooting mechanics. So meaning I want to make sure that one of these is going to shoot a projectile, whatever type that's going to be, to go until it reaches the point I'm clicking. Once it hits there, I want to expand it, so it's going to rise in size, like in diameter or in radius in general. And once it hits that point and it reached its maximum size, then we're gonna get rid of it. So this is what I want to do. Also, of course, it can, destroy enemies. Like when something gets in contact with an enemy rocket or something, whatever that is, or projectile, then we are able to destroy the projectile as well as the explosion. Well, the explosion literally stays until it's ending. Well, it's not really an explosion. Once again, it's more like an extending ball. We are going like an extending sphere. You can make this once again later on, however you love this going to look. Maybe I'm gonna go and later on and create some 3D models, some simple ones for one kind of type of prototyping stage over here. So to clean things up, or to keep things clean, I'm gonna do something like an environment empty game object pretty quick. Environment. And sometimes I'm gonna use a hashtag, so I find it easier. If you know how you named stuff, then it's also okay-ish, but sometimes it's hard to find objects. And when it comes to, like, it is hard to find, you can, make some markers here and so on. It's just an empty placeholder. You can literally just, that's not what I wanted. You can do, where is it? Reset it to be 0, 0, 0, like it is going to be in square. And once you got this, you can put everything which is based on that, which has probably nothing to do with game mechanics, or which does have stuff with main content, like the ground, the buildings, and so on. These are parts of environment. You can also group them literally together, like so. So you got more view part, or more view possibilities for the actual game view. So instead of later on going to destroy the objects we are hitting, we just probably make them invisible, which is easier when it comes to when we stay inside the scene, for example, and we need to reload. We just loop through the list of existing content, and then just instead of destroying them, we're gonna go and unhide them when they're done. This is something we're gonna go for in the optimizing state. That's what I assume. So we don't have too much, how is it called? Like garbage collection. So we don't garbage them because we're gonna use them in the next iteration, in the next round, something like that. Okay, so coming to the shoot mechanic. First off, who's going to do shoots? Well, any of them objects. And these objects can be picked randomly. For example, we can also measure distances and take the one which is closer to this point. It's also possible. So for example, if you shoot here, you better go with this one. If you go from here to here, of course, it looks different, but you don't have, we wouldn't probably have the issue of passing through objects which may or may not be in the way. So what I want to do is first I need a second rocket for us the actual, the player. What I do is first I drag the existing rocket inside the scene, and I just make sure that this one is not being tagged as enemy, so we can actually get rid of the tag completely, I would say. So but before I do it, I'm gonna do and create a new one. So in this case, it's going to be like a rocket friendly or something similar, so I know what's going on. Which one is which. I can also rename them friendly rocket and enemy rocket or something. Gonna drag it in here and make a new original prefab so I can decide which one I want to use. Also on the friendly one, I get rid of the actual tag just for the moment. So this one stays with enemy tag because it is the kind of enemy, and this one it's not. So when we are going to shoot this, we can get rid of first of the rocket script, because that is going to do different things. It's moving, but it's going to choose different things. What we could do is we could also introduce another rocket script, or we're gonna use the same. I'm gonna remove this, so we're gonna keep the stuff simple and organized, let's say. So again, this one does not have anything. If I want to, I can make the trail, instead of red, I can make the trail, or the colors over here inside the trail, I can make this more like I don't know, greenish, bluish tint, whatever. So we're gonna see a difference between the actual rockets being shot, so you don't get confused yourself, and you don't confuse the player, so he doesn't know what he has shot and what the opponent is going to shoot. So if you do any changes over here, of course, we're gonna go and override and apply them all. So everybody in scene or somewhere is going to become totally updated. The next one is we now need to go and create the mechanic for shooting that. So I probably go and make something like an input manager, or I'm gonna put them just right inside game manager. But in game manager, it's probably not as good as I like. So I'm gonna, create just a new simple script over here for just a pure input. Which input the system you are going to use is going to be up to you. I'm gonna name this input system. I don't know if that is a taken name or not. We'll see that in the fly. If not, or if it is existing in any kind of Unity spaces already, then we're gonna rename them accordingly. And of course, I'm gonna open this one up, and now I need to find a way to shoot into a 3D scene from a 2D space. And I need to do this inside update loop. Why is that? Because well, not necessarily an update loop, because but the update loop is usually the one we are looking for when we do inputs in general. On the other hand, we can also avoid using update, but we can use something like on mouse click, or on mouse over, or on mouse something. The downside on that would be we are limited to specific mouse buttons and different mouse scenarios. Instead, we would just give it like a position, whenever we do a click, we're gonna put a position, or try to get a position on screen in the world space, and then we cut away the Z-axis, because we need the X and Y to place our pointer and remember this position and store this. So the rocket which we're gonna go and instantiate, like if the timer is running out and we have the possibility to shoot a rocket, then we are able to do so. So this is also going to work on touch screens. Like if you go and later on create a mobile game, you have no issues by putting this actual input using your finger. You don't really need some kind of a touch command at all, because input system over here, by using the get mouse button or get mouse button down, is going to be the same thing as a normal finger touch. It's literally different, but it can be used or reused. So when we're gonna go and click the left mouse button down, so once, we don't hold it, we just hit it once, then we're gonna do, or we want to do something over here. So, and we need to put this into an if statement, so otherwise it doesn't know what to do over here. And 0 is going to be responsible for number 0. It's the left mouse button at our case. If you want to use a joypad, then of course you need to steer the actual crosshair, or whatever that we are going to use, or whatever you are going to use. You need to steer the crosshair with the, D-pad or something. Okay, so whenever we do this, we want to now recognize where do we have clicked, where is our current mouse position. So we need to store this information on screen. It's going to be an X and a Y coordinate. So I believe, not quite sure, but that's what I'm gonna try, is we're gonna take the mouse point. So, and the mouse point is literally the input.mouse position, it should be. Since we are in 3D space, you probably are not on the z-axis, then you need to recalculate where you are currently at. It's like where your object probably is going to be. But for this prototype here, I just know that the z-axis is going to be at 0, so I don't have to do any fancy mechanics in the calculations. I believe. Probably I'm wrong, but we'll see. So at this mouse point position, I want to position my crosshair. So for the input system, I need to have connection, any kind of a game object connection to place my cursor or my pointer over there. It could be that we need to have, since we have like different cooldowns and stuff like that, we're gonna need to instantiate multiple crosshairs so we know where we already shot. We don't know. I don't know. So you can later on also instantiate and literally just enable and disable the more you need. You can do something like object pooling. So you pool all necessary, let's say, markers on screen. The more you need, the more get created. If they got deactivated, you're going to look through the pool and see if there's some unused. Then you make them reusable. So this is called object pooling. If we need that, by the way, we can also use that on rockets and stuff like that to make them reusable, to save time or literally calculation power and stuff like that. But optimization is also something which we may or may not look into, since that is also something everybody has to do on his own and find its own mechanics to do this literally. So what I need is a public reference now to a game object. The game object is going to be the pointer on screen. I just use one at the moment. Probably I'm gonna object pool this as well. I want to place now the pointer dot transform dot position on screen. So it's going to be in the world space on the camera view at the mouse position. I'm not 1% sure about this input, but we'll see in a moment if that works or not. So every time I do a click, I want to put the pointer where I clicked. So in that case, I just gonna say, yeah, maybe just mouse point. And the z-axis once again is going to be ignored. That's what I'm gonna want to start with at very first. To make sure that works, I need a canvas and any kind of an image, maybe a little circle or something. It doesn't really matter for a prototype. We can go and update this accordingly. This is the work when it comes out of the prototyping stage that everything is going to work. So I'm gonna create a new image. I'm gonna set the canvas to be scale with screen size, make the reference resolution to 1920 by 1080, which is the full HD amount over here in a 16:9 aspect ratio. So these are 100 by 100 pixels. I'm gonna make this a bit smaller, this little image. I'm gonna rename this. This is going to be our pointer, or let's say input pointer. So we may reuse the naming conventions a bit later. Gonna make it a bit smaller. So I just scale it down. I can also do anything else. I'm gonna make it super visible. So maybe something like that. So on screen, I should be able to see this. In Game Manager, I'm gonna put now the input system and connect my new input pointer directly here. I'm gonna save that scene and go and press play and see if the pointer is literally positioned itself on wherever I'm going to click. And as we can see, this pointer is now going to go wherever I click. So I got the actual position for, at least for the moment, for X and Y coordinate. Again, since we are in 3D space, we may or may not go over and update this accordingly if needed. Like if you are not at the 0 axis on that, but somewhere, anywhere in the scene, we need to do, or usually you need to do a pre or recalculation based on the camera and so on, which is like a world point in a screen space and so on. Now, when we want to instantiate a rocket, if we can, we need to go and, call a specific function. And anyhow, the input system needs to understand if we are allowed to create a new rocket. So usually we're gonna know all the buildings. We don't have any score yet, but in Game Manager, as long as it is a static instance, we would be able to check if our cooldown, because this is what the Game Manager needs to know as well, like the interval between our inputs possible. So we can put in some kind of headers, and also we need to instantiate something from one of our buildings, or from 3 of our specific buildings. So probably we're gonna make a defender list here as well. So the defender list is going to be the list where only defenders are going to be. We can then use the defender list itself and its positions from which we want to go and shoot our missiles from and bring them to wherever they're supposed to be. The best one is whenever we perform this input, we're going to talk to Game Manager, tell, hey, please create a rocket for us from one of them 3 buildings, from the 3 or from how much defender buildings there are going to be. Probably you can later on purchase more. Maybe you start with 1 in the center and then you're gonna get more in the end. Whatever that is, this is going to be something everybody has to decide on their own. So what I can create in the Game Manager now is something like, we can name this try shoot rocket. So whenever this is going to be called, we're gonna try to shoot a rocket. This is going to be a void type, since it does not return anything. In here we wanna go for and pass over the selected position, so we can pass over the actual goal or the aim, or the position where the rocket should move to. So we can pass this over to the rocket later on as well to tell, hey, here, this is your goal position, the one we're gonna pass over. In that case, we need to implement a vector3, and let's say we're gonna name it target. The target is the click position in 3D space, since that is going to be, or has to be, a vector3, of course, as well. So from input system, we're gonna go whenever we have the possibility, or whenever we click on screen, we wanna call the actual game manager and say .instance.try to not get a component, but try to shoot a rocket. We need to pass in an information which is going to be, well, what's the point now in 3D space? Since in 2D space, the position is going to be different, because the 2D space is something like a view XY on screen. And so we need to convert the 2D position to a 3D position. I'm gonna take a look pretty quick in the Unity API, since I'm not 100% sure which one it is, but I believe it's something like a viewport to world canvas or something like that. What it does, or what it means now, we can usually try to get now the camera.main. I believe it's world to screen point, or vice versa, screen to world point. Could be this way or that way. Let's see what the actual screen to view point or screen to world point is going to tell us. What is the description of that? So in here we just have a position, and now we can see a screen space position, often the mouse XY, plus a Z position for the depth, for example, a clipping plane. Transforms a point from screen space into the world space. So where world space is defined as a coordinate system at the very top of the game's hierarchy. So I believe we're gonna have to use screen to world point to place our, let's say, vector or our target onto this one position. So instead of using a pointer on screen, we could also use something like a 3D object and place the 3D object wherever this screen to world point is going to be. Now, where's the point? Well, the point is where our pointer is. So we convert now the pointer's transform.position, since the pointer is a game object. We're going to say transform.position. But maybe we're gonna do it a bit different, since the pointer again is an object. We might gonna go and create a new vector 3 for that. So in that case, we're gonna be able to use mousePoint.x, mousePoint.y, and 0 is going to be for the z value. So also, instead of using a new vector 3, we might be able to use mousePoint directly, which is going to be once again the input mouse position, which is going to be converted into screen space. Why can we do this? Because we don't have any z value over here. So the z value is 0. If we got a different z value, then we're going to need to see and convert the z value here as well. But I believe it's going to be the same scenario literally, because we are looking with the camera onto some point in space. So that is going to be whatever the camera, wherever the camera is, or far, like a distance to the camera, and so on and so forth. So that's where we try to shoot our rocket at. Gonna save that. In Game Manager, in try to avoid that, or try to create that shot, we now need to create some more things. Gonna put some header over here, which is going to be for our, let's say, projectile, whatever that is going to be. Projectile, we need to have a public game object projectile prefab. So this projector prefab needs to have collision, detection, and all the other good stuff. And what we can also pass in, is there any need for it, is the question now. Why do we need this? Because, well, we need to instantiate something whenever we try to shoot. Another one is going to be something which might be public, but we could also make this one a serialized field. It's maybe better to protect it. Same for the coins and the score. So we can still see and manipulate them on screen, but they are literally, they stay private. So nobody else has access from outside. So they're just visible on the inspector, let's say. So we're gonna have maybe something like a float shoot delay, which we can maybe later on upgrade with an upgrade system. So we make the shoot delay in between shots, let's say, quicker. So we might want to start with some random value, maybe every 3 seconds or so we are allowed to do one shot, maybe more, maybe less. Again, this is something everybody has to get into and optimize for the own game specific scenarios. So then we're gonna have another float, which is going to be next shot, which is going to be reduced automatically. That doesn't have to be public or serialized, because this is going to count down literally before we are allowed to make a new shot. And so we're gonna have to also implement a boolean, something like we can shoot. So whenever we do a shot, we perform a shot, we're gonna say we deactivate shootability. So we're gonna say we start with a true value if we want to at this point, or we can also do this at start of the round whenever the countdown, if there is one, has happened, and so on. Again, there are a bunch of possibilities to optimize that later on. So now whenever we want to try to make a shot, we first off need to check, can we actually do a shot? If that is the case, then we want to set can shoot to be false, so we don't do this twice. So if can shoot is false, we're gonna know, or we cannot do a second shot afterwards. Now what we want to do is we create a new game object, and this is going to be a new missile or new rocket or new something, a new rocket. And in here we want to go for and instantiate this one. And now we need to find out, what do we want to instantiate? In our case, it's going to be the projectile prefab. Now we need to define a position. And as I said, we can make a defenders list. So we can say public list of type defender, which is going to be our upgradable buildings literally. We're gonna name it all defenders or defender list equal to a new list of defender. Buildings are not defenders. Do a throw the hierarchy I just built it up in the last video or in the last live stream. Now we're gonna pick a random defender, at least for the moment, and shoot a missile from that one defender. On the other hand, what we could do is we can say who is the closest to the target point, and we're gonna use this one. So both versions are interesting, let's say. So the closer the target to the defender, we are currently maybe looping through, check who's the closest, and return the result. In that case, we would need to go and do this at the very first, before we actually pick the corresponding, let's say, position, because, well, we don't really need the defenders themselves for this, but we need their positions. To do that right now, we're gonna pick a for loop. In some cases, you can hit tab twice. Over here, we just don't. I'm gonna use the all defenders list, and I'm gonna start before we go and do this, we're gonna go and store, let's say, vector 3. No, what do we want to know? We want to know the best defender, actually. So who is the closest to, who is the closest defender to our target, where we want to put our stuff into. So we could say we're gonna pick one or create a new one, or just have a temporary defender here. And this is going to be temp defender is equal to null. So it's just nothing. And now it tells us we don't use it. So make sure we want to use that. So we now need to measure the distance. And whoever has the smallest distance over here, it's going to be the defender we want to use or override. And then we use the defender's position, the temporary defender's position. So to do that, we're gonna know, or need to know, well, first off, we need to get rid of this because we want to just loop through all the defenders.count. Now we want to measure the distance. So we take a float variable. I'm gonna take another one maybe here as well. Float smallest distance. So what we want to do is we want to loop through all 3 of them defenders. So that's what we currently do over here. And now we want to see who has the smallest distance. So for that purpose, we're going to need to create a dist check and see if it is smaller, bigger, or whatever than the smallest distance. The issue over here with the smallest distance is if we are at the first iteration, we need to take whatever it is. So if we are at index I1, we need to override smallest distance at the first place. And afterwards, when we don't do this, we just check against the smallest distance. So for the distance check, we're going to use a simple vector2, vector3.distance check between 2 points, point A and point B. Point A is going to be the actual target. So from the target to the all defenders dot transform dot position. But I believe it's going to be, we need the actual I here first, dot transform dot position. So we compare, or we measure the distance, like the direct distance between target and all defenders transform, and store this inside distance check. That's what we're gonna do in each of them iterations. Now we want to see one thing. So if the smallest distance is still 0, which is literally impossible to be used, if the smallest distance is equal to 0, we're gonna do this only once whenever we do one shot. So it's reset every time. If the smallest is equal to 0, then the smallest is equal to the distance check. So we just override it instantly. If that is not the case, or let's say smaller than, it tells me that float is literally not funny over here. So we probably check against I. So if I is equal to 0, then because I is going to be of type integer, then we're going to override smallest distance. So we don't have this weird float integer confusion with like, see if that is 100% a 0 position or a 0 number, which is usually passing over problems. If that is not the case, we can put in an else statement over here. Else, we want to see who's bigger. So, or no, in this case, we want to use who is the smallest. To use that smallest, we can always compare two things. We can use the min function, which is not sitting in mathf, but in math of the .NET library. So we want to now set smallest distance to be equal to, now we need to pass in system.math.min. We want to get the smallest of 2 byte or 2 whatever values. The minimum check over here is going to be between the smallest distance and the actual distance check. And whatever that is going to be is the one we want to override here. What is going on here? Good question. Why can't I take this as being measured? There's a non-used. Did I have a typo? I don't know. Maybe I'm gonna make it a 0 first, yeah? Okay. So I need to make it so that it has a 0 first, then we're gonna have the distance check, and the smallest is going to be whichever. And if we're gonna go and override that, we also need to set the corresponding defender. So the first temporary defender over here is going to be equal to all defenders in square brackets I, so the one we start with literally. Now when we update smallest distance, and if that is going to become updated, then we need to update also the correct or the current defender. So I believe we're gonna have to do this a bit different. So the minimum check is maybe not a good one at our case. So we need to do this with an if statement. Because if the dist check is smaller than the smallest distance, then we wanna go and override smallest distance to be equal to distance check, and now we can update the temporary defender. So temporary defender is equal to all defenders in square brackets I. Otherwise, we wouldn't be able to override it by using just a min-max or the min value over here, because we only get back the distance, but we don't check is it now smaller or whatsoever. Over here, we can also use smaller or equal, then we can also update this accordingly. Now we know the defender we want to take the position from. So in here, we're going to set now the temporary defender. I hope it's available. Yes. .transform.position as being the actual position over here. And then the last one we need is a rotation. So basically, we're going to use or start with quaternion.identity. If you later on use spawn points when you want to have a specific outlet of whatever you are shooting, then of course you're going to take the defender's spawn point over there. So again, to recap, if we can shoot, we're going to set shoot to be false. We're going to do all of that stuff, and then we instantiate one rocket. Now what we need is we need to have some kind of a timer which sets can shoot to be true again. We could use some kind of an invoke method, or we can use a coroutine. Both works perfectly. So what we can say, we create a little timer reset function over here, or we just call, we need to have some kind of a timer. So in that case, it's a void, let's say reset can shoot. And literally we just call this from an invoke in which we just say can shoot is equal to true. To invoke that, we just need to say first, after we have instantiated our object, we can say invoke. Try again, invoke. And now we want to invoke what method? We want to invoke with strings over here and say, now we want to invoke this like directly afterwards. We want to invoke this method and no, we don't want to do this instantly. We want to do this after 3 seconds over here. So again, the invoke method is going to be called after amount of seconds we're going to pass in. So currently we're going to use this by hand, but better we're going to use this shoot delay number. So instead of doing this, we're going to use shoot delay. And so we would be able to, do this. If we cannot shoot, we can also say, just don't go further in the code, just return. So we can say if not can shoot, why ever, because, well, it has not been reset. We just can return. We don't need to go through all the other code over here. We just return and we are good to go. Reset shoot should be good to go after 3 seconds at least for the moment. Now we need to fill in defenders. So I don't know where my window is over here. I have this one on full screen. No idea why. So in our input system or wherever in our game manager or in my game manager, I need to fill in now the defender buildings, which are of type defender, of course, so which are inside the scene. So all defenders are fit in, but we cannot place any buildings. We can only put in defender over here. I make this locked, select them all, and pass them into all defenders. If I try to use a building, it's impossible because, again, a building is like in a different object, literally a different type of object. So now we got all of them 3, and yeah, whenever we can, we should be able to instantiate an object. And this object to be instantiated has to be set by us also here in the system under the Projectile tab. So we go to prefabs, rocket friendly, and there we go. But the rocket cannot fly at the moment. We need to make sure that the rocket is able to go to the point in space which we have clicked in 2D space. So how do we do this? Well, we need to write a script, of course, which takes the input from the goal position and, of course, fly to this point. Literally, we could maybe reuse the rocket script we already got. We can take a look pretty quick. The actual rocket we currently have is going to have a speed, starts a coroutine, does its move until it hits the point. Basically, that's fine and literally also reusable. So maybe instead of going for a new target, we cannot use that directly, but the issue is literally going to be the same. We're gonna pass over just the vector where we want to move to, and so we cannot really use this rocket. So to do so, or to do different now, we're gonna create a new friendly rocket. Sounds a bit weird, but that's what it is. Friendly rocket. And this is the script we're gonna need to put on our rocket prefab. So I can select it over here. Why do I get this here? Okay, because of the lock symbol or the lock sign. I'm gonna use the so-called friendly rocket over here and open this one up. And we need just some input. Well, we don't really want to call this at start, because at start it doesn't know where to go to. At start it only knows where it is at the moment. So instead of using update and instead of using the start, I'm gonna use, well, first a float with a speed, which is probably later on also upgradable. We're gonna maybe connect the speed variable of our own rocket inside the game manager as well. So we can maybe upgrade this accordingly. If that's needed, well, let's keep it over there. Maybe you're gonna go and update this one if you want to, like rocket speed or whatever. But I don't think that is necessary. Once you have balanced this one out, it should be fine over here. I still make this one a serializable field, so we can change the speed in the direction in the inspector at any time. So what next? We need a public void function to set the rocket up. So set rocket target or something similar. It's not just setting the target, but it also makes it fly to the point where it's supposed to be. So we're gonna, from outside, we're gonna set rocket target by our input system, which talks to the game manager. The game manager says, hey, shoot a rocket to this point, because the game manager is the only one who knows about this goal or the set goal. We could also say, okay, friendly rocket, request this from the game manager. That would be also possible, and then move to, but maybe that's a bit too, I don't know, not too obvious. To get information from somewhere, we better send it to somewhere. That's probably better. Also, the rocket later on, when it is at the point where it is supposed to be, it has to instantiate the ball, which is going to increase its size, like this kind of explosion thing, which just grows to a specific point, like using a scale parameter or something, I don't know yet. And then when it reached the maximum of the scale it's supposed to be scaled to, then it might be gone and just, gets rid of itself. So to set the rocket's target, we first off need to pass in the goal vector or the target vector where the rocket has to go to. And in here, we just want to pass over literally the same stuff as we did with the rocket. So I'm going to use or just get the information from here over here. But we don't want to get a target from game manager. We want to get the target from the actual game manager, yes, but from the click we just performed. So I'm gonna use new target as target over here. We're gonna move to this point, and once we reach this point, we can do play explosion or whatever that is going to be. Explosion, scale, stuff, whatever. In set rocket target, we want to just say start coroutine, and now we need to pass in first of who and then which are the parameters. In our case, it's the target. So that's for the moment it. At the very end, we may or may not want to go and destroy the rocket or object pool this. So we can just say destroy rocket once it has, reached the point. So we can say something like destroy game object, at least for the moment. Now we should have everything set up. The rocket now needs to call or get called. So whenever it gets instantiated, we need to talk to that and say, hey, here's your target, start your coroutine and do this stuff. So to do this, whatever these are, I don't know. To do this, we're gonna go back into our shooting mechanic, and after we are done instantiating this particular rocket, we should be able to talk to it. So we're gonna say new rocket dot get component of type friendly rocket component friendly rocket open close parentheses dot set rocket target, and the target, as we just noticed before, is going to be this target. No, not this one. But where is the actual target? The target is going to be here. This is the target where we want to send our rocket to. Don't forget to save. And now let's see if we are able to perform this. Of course, we can also hide and unhide the cursor if it's like, not used or something. But let's see what's going to happen when I press here. We get a null reference exception. And this is trying to do, well, what? Double-clicking it usually gives us a line of sight and says, okay, where is the actual component on our rocket? Probably we don't have this on our friendly rocket because we haven't overridden the actual prefab. Now I can get rid of the prefab in the scene and try again. I'm gonna shoot here maybe, or click anywhere. But where's our rocket? Our rocket is going to be in any weird direction, but it's not really going where it's supposed to go to. So it flies to the camera. It does not fly to the actual, we can test this out again and check this one here. So the camera.main screen to world point is actually wrong, as we can see. There we go. Missing reference exception. These are coming from the not existing buildings anymore, I guess. But this one here is pretty interesting. Maybe I made the mistake. Projectile prefab. Nope, I didn't. And yeah, these buildings are just going to be destroyed, so we wouldn't be able to shoot a new rocket if there are no defenders left. So probably that's why they were not available, let's say. So now I need to fiddle out a way how I can place or shoot the rocket onto my Z value over here. Like this Z value is going to be the position. The mouse position seems to be somewhere here. So maybe it's something like in the input system, instead of using screen to world point, we probably need to do something similar, something different. So probably something viewport to screen point or viewport to world point. Let's try this one. I don't think that is the one, but we'll test it out. I could also read about it, but there are not so many possibilities to get to a point whenever we click. So where is that going? This is also going to the camera. So this is also wrong. Maybe the Z position is the issue over here. So we may need to go and pass in the Z position not being the position of the main object. No idea. Let's see. What else could we try? We could say screen to world point is maybe the one. Didn't we have this before? World to screen point. What could that be? Let's try. I don't know which direction that is going to be. World to screen point, screen to world point. I just don't know. That kinda... Well, where is it going? I'm still looking and seeing where it's supposed to end. Oh, I believe it's going to go to this point here now. That's what it looks like. It's a bit slow. Maybe I can speed it up a bit. I don't know where it sends it. So let's find out which one is going to be the one. Maybe it's not even camera.main. Maybe it's just a world to screen point something scenario. Let's see. I'm gonna check the API for that. Screen point to Ray, maybe. Camera.main.screenPoint to Ray. And the Ray is going to be our mouse input, literally. So that's probably the one we are looking for. Argument connect convert. What does it need? It needs a vector 3. Let's convert this one to be a vector 3 then. Okay, it has to have a actual raycasting hit. That doesn't look nice. So let's see what else could we do. Because we're not really shooting a ray into the scene. Screen point to ray position. Screen point to ray. Near and far plane. That all does not look correct over here. In 2D space, that might be easier. So in 3D space, we may or may not need to shoot a ray. Since we don't have literally any position we are touching in general, like an object, so we cannot directly use that thing. So I believe the screen to world point is not the wrong, not the bad one or not the incorrect one. So I just need to define the Z position, which is going to be some point. So let's try again. Screen to world point. I'm gonna use screen point to world point. I don't know if I already tested this one out, so let's try again and see if that is the correct one. I don't know. I barely use that. content. Maybe I could use the pointer, but it's not like, probably not going to be correct here. So let me try again. There are some mistakes here, but that's fine. Yeah, so it still tries to go to the camera, to the Z position of the camera inside, I believe, the near plane or something like this. So if we see this, it reduces the camera, or it goes to the camera's position. So currently it's on Z minus 13 something. So I may need to split the actual position up and take the negate the Z position, or the Z position from the camera from the actual mouse point area over here. I believe there's a possibility for that, but let's try this first. To rip it apart, I just create a new vector3. Maybe it's going to be our I don't know, point. For the moment, it's going to be new vector3, and what we're gonna take is mouse point, well then I don't need anything else. Mouse point dot x, comma, mouse point dot y, comma, and now we take camera. We take, yeah, what is if we use 0 here? What is this 0 meaning? Is the 0 meaning the actual 0 position of the camera, or the 0 world space position? I believe that's going to be the point of interest when we just zero. Well, that's what I hope. When we just zero out the Z value. So we go to the screen to world point and the 0 position. Let's see if that works. No, it does not. So I'm gonna try camera dot main dot transform position Z, but in here I'm gonna negate it. Let's see what that does. So we are still going to be on the 0 axis over here. So now we get an actual system. Missing reference exception. I don't know why we get a missing reference exception. Oh, because of the destroyers might have been destroyed beforehand. So let me disable this spawner for a moment so we don't lose any objects. And it's not spawning anything. And we can try to play around. We're gonna have the delay of 3 seconds. And the object of interest is going to go from the, let's say, closest point, like from here or from here, and takes this closest point now to shoot to the position we are literally after. At this point, once it reaches this point, it it destroys itself. But now we want to have something which is growing in its size over over a size X, or from size X to size Y in a specific, let's say, amount of time. For doing that, I just create a rather small sphere. First off, zero this one out, reset. It's too huge to have a beginning at I believe. I mean, let's make it a bit smaller, right? So I'm gonna go for a scale of 0.1 by 0.1 by 0.1. So X, Y, Z are going to be 0.1. Now I go, and what I could do is I could animate the sphere size. What I don't know is if the collider is animating with it. That's what we want to go for. I'm gonna tag the sphere as being, well, it's not going to be an enemy. It has to be like friendly. So if it hits something of its own, then whatever it is not going to be hit by that. Friendly. So we got enemy and friendly. And I'm gonna tag this one now as being friendly just in case. So if a rocket hits a friendly, the rocket gets destroyed. And if a rocket hits, you know, a building, the building gets and the rocket get destroyed as well. Or just, you know, stored somewhere. Now we go and animate this. And I'm not quite sure if animation is better than scaling this over time, because we might increase the scale later by whatever. And so the explosion might be, if we are calling this one explosion, might be bigger after a couple of times. So if it is an upgradable in its size, as an example, we want to go for and see what is the size of the actual explosion over here. So the kind of the current scale. And until this point of scale, so the smaller or bigger we're gonna make it, until we reach this point, we're gonna have to, let's say, upgrade this. And whatever the speed is to reach this point, it's going to be like a scale speed, which we're gonna put maybe directly in the rocket, but in the game manager, we want to make it so that we have a serialized field, maybe just for that. And since it is part of the upgradables, we could put it over here and maybe also put some header over there. I'm not quite sure if headers work over serialized fields. That's what I just don't know. That would be something we would have to take a look into. So I'm gonna make it a serialized field here as just in case. This is going to be the let's say explosion radius. It's going to be a type float, since it is later on upgradable by 100 or 1,000 times with some kind of a multiplier. So explosion radius, this is until that point we want to grow our projectile. So let's start with a 1 or 1.5 f. So we're going to have a possibility to read or reach something. Now, instead of using an animation, I better go for and use code to scale this. And once it has reached the code, it gets destroyed. To do so, I need to have another script. This is the final something I'm going to pass over here in today, is create a new C# script explosion, which is going to be our scaler literally. And we want to scale this one based on the information we get from the game manager. I also named this one here explosion. And if I scale it in here, I believe explosion, I believe the actual sphere collider is scaling with it. To do so now, I'm gonna go and put the explosion script on top of that and open this in monodevelop. So in start, whenever this gets created, we're gonna store our, let's say, goal scale. Goal scale. Open close. Well, actually, not open close anything. Goal scale is equal to game manager instance dot. And now we don't have the explosion radius to be accessible, so we're gonna, or our explosion radius, I'm gonna make a little helper function for that. Just collapse some things here. In that case, I'm gonna create a new float. It needs to be public. Public float get explosion radius. And here we just return explosion radius. So we're gonna do this every time, since that is maybe later on again an upgradable, you know, something, an upgradable information. So in here we can just say get explosion radius, so we know where we want to go for. And also at start, we're gonna call a coroutine, i.e. numerator, and I just name this one grow. And in grow, we just wanna by time increase scale. We can make a scale speed if needed. Float scale speed if we wanna, increase the speed by anything bigger than the normal game speed. In here, we're gonna just say transform dot scale or local scale, and scale is not available, so we're gonna use local scale is equal to something. And we're gonna need to say while local scale, so transform dot local scale is smaller than scale the goal scale. We're gonna say transform dot scale plus equal time dot delta time. So the past time is going to be our scale vector or scale value. If that is possible. The scale vector is a relative, so the goal scale has to be a vector 3 over here. So we're gonna make it maybe like we pass over vector 3, n scale or target scale is equal to a new vector 3, and now we pass in 3 times goal scale. Copy. Paste. Oh, comma, paste. So, and in here, we're gonna pass over target scale. So we get the, we cannot compare it. So we can maybe say not equal. Not equal doesn't really, I don't really like this. So probably we're gonna measure global or local scale X to goal scale. Or actually smaller than this, because we're gonna grow local scale over time until this happen. And local scale is not being increased or increasable by that. So I'm gonna need to fiddle out something. I'm gonna make a break over here for a moment, and I'm going to be back rather soon. So for the rest over here, I'm gonna split that things up. So I'm gonna go and instead of using some kind of a target scale here, I just maybe take them all separately and fit them accordingly. So maybe I override a specific something. So when I go into the grow, I might go and cover or take the current local scale first and catch that. So I'm gonna say vector3 current scale is equal to transform.local scale. So I know where I actually start, and maybe I can compare it with that sooner or later anyhow. So now, meanwhile, I want to increase that. I might take, instead of using current scale, I could also do something else. So maybe just any kind of a current scale value, but not being a vector, but a float. So I can override the actual float with other floats. So I'm gonna take current scale.x over here, so I have a starting value, so I can also compare the current scale with the goal scale. So meanwhile, the current scale is smaller than goal scale. I want to keep on scaling. To do that now is a bit different. I'm gonna say current scale plus equal time to delta time. And we can also multiply that by speed, I guess. So our scale speed is going to start with 1 over here. So we just multiply by that. We can now increase and decrease that. Now we need to set the actual goal or the actual the actual vector or the actual current the current vector. Let's do this pretty quick. Vector current scale is equal to, well, we're gonna start with the transform.local scale. Local scale. Gonna name it maybe current v scale. Copy this, and now I override current v scale. And in this case, it's going to be current v scale is equal to, I believe I now have to update this accordingly. To always take current scale in x, y, z coordinate. Something like that, maybe. And now at the final step, I need to say or set local scale on the transform of the ball to be equal to current v scale. Because that's a vector we are literally manipulating now. So we start at transform local scale. We set current scale to this one. We now increase current scale by time.delta time times the scale speed. Now we're going to pass that information over in a new vector and update current v scale. And the final step is we're going to pass back the information to the local scale. I believe there's no other way to do this. So meanwhile that is happening and this is smaller than the goal scale, then we're going to continue this while loop. Once we are out of here, we can literally just say destroy the game object. But not point, but in parentheses. We don't yield anything, so we're going to yield return null maybe over here, until we are done with all of the scaling. And the final step should be, we're going to start a coroutine, and it's named grow. Now we need to make the friendly rocket create this explosion for us. If we want to, we can also do this for the other rockets. So a friendly rocket now needs to have a connection to a prefab. So we're going to create a new game object or public game object, which is going to be the so-called explosion, whatever that is going to be. Could be even a bubble. Then whenever we are, before we destroy the rocket over here, we're gonna say game object. Oh, we don't need to do anything to this. We just need to instantiate it. Instantiate explosion. gonna maybe rename this to be explosion prefab, so I know what's really is it about. Maybe I have multiple ones or multi names later. Add a position, and the position is going to be where our current position is. Transform dot position, and this rotation is going to be quaternion dot identity. Should be it. Should grow then automatically, because in start it's going to take the information from game manager, starts its own coroutine, and destroys itself after the scale has happened. So the final thing is we need to make a prefab out of explosion, and we need to put it into the friendly rocket. So first I'm gonna take this one here, select rocket, and no, we don't select rocket but friendly rocket, and now we pass in explosion prefab. Don't forget to save, and let's see if that works now. I disabled the spawner so it's not in the way and doing any fancy things. So fun part is the scale worked, but I still have the prefab in scene, so I'm gonna get rid of it. And now we want to shoot to a point, or here, and now we got the scaling up. And when something is, getting hit by the scale up, we are able to do damage. Probably it's going to be a bit too small or too slow in its growth speed, so we can literally decrease this number to be, something like 0.5. If that number becomes smaller, no, it has to be bigger. Let's say double speed. So we multiply the current time.delta time by the explosion speed grow. Let's see if I have a grow parameter open. No, I don't. So it's private and I can just do this internally. So it should now grow quicker. So rocket goes there, it goes up, and then it's gone. Pretty good. If the size is not going to be 100% good or something similar, then I can actually go for it. Last but not least would be in our rocket itself, like in the bat or in the enemy rocket. If the enemy rocket gets hit by some friendly explosion, I would say, then we're gonna go for and destroy the rocket. So basically, we're gonna use the so-called void on trigger enter. We could also do the opposite. Basically, it doesn't matter which one is which and who is going to check for things. Like we can make the rocket check it, or we can make the ball or the explosion check it. Both should work. So if the other collider is going to have the friendly tag, so if other dot compare tag is friendly, we're gonna destroy this game object. Once again, we can also go and pull it, but that is not necessary at this stage. So optimization for code can always happen from any side, from everybody who wants to. So for the spawner, I am gonna go for and open pretty quick. Because I want the spawn delay to be set in scene, so we can make this one open for us. Maybe the delay is a bit too heavy, so I'm losing too much. Maybe also the fly rocket speed is too big and so on. I don't know. But now I can go in the spawner and manipulate the number to be, let's say, 2. So I have a bit more time to react to it and see if I am able to hit one of the rockets and destroy them. My rocket is too slow. So the opponent rocket is way quicker, it seems. So the rocket has 3 speed, and my friendly rocket also has a 3 speed, but it's still moving slower. Actually, that's what it seems. Which is pretty interesting, actually. They are using the same mechanic. They have the same speed. Well, I think so. Maybe they don't. Maybe the shooting mechanic is too slow. Okay, so maybe the explosion radius is also growing too slow or getting created too slow, something like that. There are a bunch of possibilities over there. It also does look like explosion. Well, once it is at the target, it should be instantiate this and then destroy the object. Literally, that's fine as is. I just don't know. So in Game Manager, since that is a serialized object right now, a serialized field for the actual explosion radius, I might go and make this one a bit bigger to see the impact. What I need over in one or the other thing is going to be a rigid body component. So this one has to be a trigger one, and I need a rigid body. The rigid body should not have any gravity and nothing else. Gonna save that, and now the rigid body should also trigger that it can, if it's getting hit correctly, or possible to hit any of the rockets. Kind of tough run, so maybe need to increase some speed here and there. Gonna try to. The explosion radius is really small. So I go in the game manager and change the explosion radius to double, let's say with 3, and see what's happening. Again, this is something everybody has to check for on its own anyways. So yeah, it works. The grow might have to be a bit bigger, so the impact of the starting explosion size have to be increased, I believe so. So meaning we are not starting in a super small scale over here, but maybe in a 0.5 by 0.5 scale or something. So we are actually able to hit something on impact directly. And maybe we're going to increase the scale speed of that explosion a bit as well. So scale speed, explosion radius. I don't have the scale speed directly inside that, I should say, or I bet. Should delay the scale speed. Where's the scale speed? Should be here. So maybe I need to double even that further, maybe to make it a 4 or something, so it's reacting a bit quicker, so we don't miss too much of them. Once again, this is something everybody has to take a look into on his own. So let's try to hit something. My rockets are pretty slow over here in well, they're pretty slow. Maybe I need to make them a bit quicker so the friendly rockets are flying faster, maybe than the enemy rockets. Otherwise, it's hard to hit them. So going into prefabs, friendly rocket, and increase the speed to, let's say, 4. So they are maybe a bit faster, and we are able to catch up. Maybe I'm gonna slow down the other rockets. Like the enemy rockets, they are pretty fast here as well. So, gotta make this rockets. They do have this internally. Maybe I'm gonna give them half of the speed, like 1.5 F. Need a semicolon. Oh, the semicolon is just there. Maybe I'm gonna serialize that field as well, so we can still put them or work on this in the inspector, but we cannot manipulate this on other things. So now it's a bit more for us and working for us, and we are able to shoot some things over here. Hope we're gonna be able to hit one or the other. The actual shoot delay is also interesting. One of my defenders is gone, so we should still go over and have stuff to optimize or to be optimized. But that's one part of another video, and one part of another live session. I believe this is a pretty good start so far. If you have any questions, as always, feel free to ask down below in in the comments. If you like this video, don't forget to thumb this one up, as well as don't forget to subscribe to the channel if you haven't already. And if you later on want to purchase the final product of these, because it's a bunch of work to do still, then I'm gonna go and put this onto my website, and you're allowed to do so. Have a good one. Enjoy the week or the day or whenever you're looking this video, or even the night, and talk to you later. Bye bye.